All right, we're going to review Unit 4, which is on functions. And this one's pretty fast. Excuse me, there wasn't a ton, or I guess I should say, of information in this unit. So first off, a couple of vocabulary words might be new to you, and that's domain. Domain is a fancy word for talking about the x values. So those are the ones that we always start with. Excuse me. We always start with the x value. So that's our input. So if you think, we talked about like a function machine. And the first thing we always do is we put a number in. Well, that's what the domain is. So the domain is the number that we're starting with. So let's just say that we have points 5, 2, 3, 7, 6, 2, yikes, and 4, 1. All right, if we were talking about the domain, we would say, oops, that was awful. Oh my gosh, I don't know what happened. I don't know if I hit a bump or what, but I got to fix this. So, good grief. All right, let's try this again. There we go, that's better. All right, so our x values, if I look through, I have a 5, I have a 3, a 6, and a 4, and that's it. Now, nobody said it has to be in order, but typically people like it in order. So a better answer, and what you need to watch for, is to say that the domain would be 3, 4, 5, and 6. Now, you might be saying, well, can't I just say it's 3 through 6? But here's the issue. There's a whole lot of numbers between 3 and 6. And that's not what's happening up here. We don't have any fractions or decimals in our domain on these points. So we wouldn't say the domain is 3 through 6, because that would imply that every single number between 3 and 6 is included in our set of points, and that would not be true. So we do list them separately with commas in between. All right, range, same idea, but this time we're talking about the y values. So using these same points, our output is what we get once we fill in a number into an equation. So we fill in an x, and the answer we get is the y. So if using these same points, I would say that the range is 2, 7, 2, and 1. But let's fix this up a little bit. First of all, they're not in order, and I have the same number twice, which I don't need. So I'm going to fix this by saying that the range would be 1, 2, and 7. And that's the best way to show our answer. All right, next up, talking about a function. This is a difficult concept to understand, but as you get further in math, there's lots of different types of equations, and somebody, not me, decided that a function would be a relationship where each x value is different. So we're not going to have two of the same x's. So as you noticed right here, we had a repeat in our y values, but we did not have a repeat in our x values. So that would mean that this set of points right here would be a function. So what you want to do is make sure that all x's are different. If all x's are different, then you have a function. All right, so let's say we had 3, 7, 2, 6, 1, 7, 5, 3, and 2, 3. So if I look through this, it doesn't even matter what the y values are. So I really don't even need to look at those because that doesn't determine a function. What determines a function is that all the x's are different. So that one's okay, that one's okay, that one's okay, that one's okay. This is a problem because I have two x's that are the same. So this is not a function. So all of the x values have to be different in order for it to be a function. All right, vertical line test is what we use to determine if a function exists when we look at a graph. So let's just say that I had this right here, okay? What I'm going to do for the vertical line test is I'm going to go through and I'm going to draw a vertical line at any spot. And I can only hit what my graphed function is one time. I hit it once, 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 I hit it once. If you remember when we talked about this in class, I gave you a little piece of spaghetti and we kind of rolled it over to see if we would ever hit whatever our graphed function is more than once. So this one right here is a function. All right, let's say I graph a circle, or maybe that's more of an oval, or maybe that's just a blob. All right, so what I'm going to do here is I'm going to check and see if I hit any points more than once. Uh-oh, I hit it twice. I can already stop because if it only happens one time, it's still not a function. But in fact, this happens over and over and over again, that anytime I draw a vertical line, I'm hitting my graphed equation more than once. So this one is not a function. So that's what the vertical line test is. Now, just to make this clear, the reason why we use a vertical line is because a vertical line is not a function. So when we use a vertical line for the vertical line test, that tells us whether it's a function or not. All right, next up, independent and dependent. So the deal here is that going along with domain and range, we start with the independent variable first, and what we get is the dependent variable. So going back here, domain is always the independent variable. It's the input. It's the one that we fill in first. And what we get is the output, which is the dependent variable. All right, easiest way to think about it is to complete the sentence, the blank depends on blank. And the dependent variable depends on the independent variable. So let's say, for example, if I make up a sentence and I say, the total depends on how many I buy. The total depends on how many I buy. So the question is, what's the independent and what's the dependent in this situation? Well, the total depends. So I know that my total is the dependent variable. And the independent is how many I buy. So the independent would be the number of items. Because my total is going to depend on how many items I buy. All right, last one, a linear function. So this is building up to Unit 5, which was the entire unit on linear functions. But a linear function is a function that creates a line when we graph it. And it always follows the form y equals mx plus b. If you can't fill in y equals mx plus b, then it's not a linear function. All right? A linear function makes a line because there's a consistent pattern. So if you think about graphing a line, I'm just going to do some dots. This is what's going to be a linear function because as I connect these points, those points fell in a pattern, and that's why I was able to make a line. Okay? So I know this is a linear function because for one thing, it made a line, there was a pattern in my points, and if I did a vertical line test, I'm only hitting my line once. So this is going to be a linear function. All right, now to show you one that isn't, let's say that I draw this. All right, well, first off, I don't have a pattern going on here, but let's just say I connect the points anyways. So if I go like that, I know this is not a linear function because I didn't make a line. I made a zigzag, or I made a couple of little line segments that are all pieced together. So there wasn't a pattern in my points there. I can't write it, and if I do a vertical line test, whoops, I hit a whole bunch of points right there. So this is not a linear function. All right, now you might be wondering, well, what is a function that isn't a linear function? Well, you learned in science that we have waves. You probably learned about sine waves. Well, this one would be a function, but it doesn't make a line. Because a line in math is a collection of points that extends in both directions forever, but there's no curve to it. It's just a straight line. All right, that takes care of Unit 4, which was the basis for our Unit 5, which is our next unit.